Hello and welcome to Nelson's Corner, episode 15. This is part 6, continuing with the card game engine. Tonight, of course, joining us, our host, Mr. Nelson Lakay. Hey, Nelson.
Hey.
Also, our new and improved student, Mr. Gavin, who does such a better job than both Zach and I put together. Gavin, how's it going?
Hey, not so bad, not so bad.
And we also do have Zach.
Hey.
And myself, Jason Busby. Also joining us, listening in, is Mr. Thomas Lay. If I'm saying that right, hopefully so. But T-Gun from the site, for those of you that know who he is.
He's the silent partner.
That's right.
But he is here.
That is right. So continuing with where we left off, the last video in part 5, Nelson, you had set up a lot of framework stuff, really no implementations, but I believe you're going to begin with pregame implementations in this video here?
Yeah, we're going to go ahead and get the infrastructure set up so we can start getting card types loaded into the runtime.
Okay,
That's
fantastic.
The goal. All right, so the first thing I want to do is I want to go ahead and implement this read-only dictionary, just because he's kind of sitting out here, you know, all alone. He's kind of a utility class that we're going to need later on. Once actually we can immediately use him after we finish implementing him. So I'm going to do that first.
Okay.
So I'm going to go ahead and create a read-only dictionary class who's going to implement. I cannot type key t-value. Okay, so these are all the things that we have to implement for him. Basically, all he's going to do is he's going to wrap an iDictionary, and he's going to basically defer everything back to the iDictionary. So, if that makes sense.
Mm-hmm.
So here's his little private implementation. And he's going to have a constructor that's going to go ahead and take an IEnumerable of key value pair. I'll talk about this in a second. Hey. Okay, so the IEnumerable of key value pair, dictionaries, if I go ahead and control click on this guy, you'll see that the dictionaries actually implement IEnumerable of key value pairs.
Mm-hmm.
So by accepting this argument, we can pass in existing non-read-only dictionaries just straight to this constructor to get it loaded up with the data it needs. But the idea about the read-only dictionary is it's going to take in all the data it's ever going to expose through its constructor, and it's never going to allow that data to be changed.
Okay.
So what we're going to do is we're going to do values.toDictionary, which of course hasn't been imported yet, so we bring in using system.link. The key is going to be key value is going to be value. So basically all this line is doing is it's taking this IEnumerable of key value pairs and it's instantiating a new dictionary and copying every key and value out of it into this new values doohickey.
Right.
Mm-hmm.
So for getEnumerator, it's just going to be basically return values.getEnumerator. That's fine. The explicit implementation of IEnumerable.getEnumerator, the non-generic cruft that is left over from the prehistoric .NET 1.1 days where generics didn't exist, and I hate the fact that this method has to be implemented. But it's there anyway, and all it does is defer to the genericized version that we have right here. Count is actually going to be moved up above the constructor as where all properties should go. So is the indexer. Count is going to basically... I don't know if you guys could have guessed this or not.
Return values.count.
Right. And my formatting is being lame.
Hey, we're on your computer, so no complaining.
It's the lag, definitely.
It's on his machine now.
All right. So the indexer is going to go ahead. And I don't think we have had a Nelson's Corner about indexers yet.
No, we have not. If you want to take a second to explain for somebody that, Gavin, are you familiar with indexers?
No. Short answer.
Rats, I thought you were going to say yes, and I was going to start quizzing you. Okay, Nelson, go ahead.
All right. Well, indexers are properties that you can access directly using the bracket syntax. So, for example, if I were to have a class list of stuff, and he had a public int this int index. I'm not going to get the syntax right, even though it's right below me. I've just never written an indexer for a very long time. get return, I don't know, index times 2 or whatever. Actually, what it does doesn't matter. So then if I were to go ahead and use this class called list of stuff, check this out. Let's just imagine I have this program method down here, and it has a static void main function, just like if it was a console application. And I go ahead and instantiate a list of stuff. I can now do this using the bracket syntax, just like what you see with dictionaries and and whatever. So that's really cool. And you can also pass in multiple arguments. So if I wanted a two-dimensional array kind of syntax, I could do that. And so on. And I can have a getter and a setter and blah, 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 blah. So yeah, indexers just allow you to access stuff through an array syntax.
Very powerful.
So that's what this is here. This is just a generic indexer that, well, again, virtually defers back to the values indexer. Our contains is just going to return value.contains key, or contains key. Try get value is just going to go ahead and return values.try get value key out value. So there, that's our read-only dictionary class. And so let's go ahead and actually use this implementation now by going over to our casting cost, because that was originally where we've been using this read-only dictionary. Basically, just to reiterate why we have both this syntax to access it and a read-only dictionary to access it, is if I wanted to write some procedural code that enumerated over every single color in the casting cost, it's a lot easier to loop over a dictionary than to have to write reflection code to grab all these properties, if that makes sense.
Yeah.
But in other cases, I might just want to do .bluecost, and it would just look a lot cleaner. This is just about how it looks to access it.
Right.
And because everything is immutable, there's no way that these two ways to access the same data could ever become out of sync. So our colors is going to be a new read-only dictionary, and then we're going to pass in a new dictionary, actually, and then we're going to use the dictionary, dictionary initialization syntax to go ahead and initialize all these items. So basically just a lot of mindless typing that I seem to be very bad at right now.
Your brain's more awake than your fingers.
Yeah, that's quite possibly. Or I spent all day at work typing out forms, literally. My fingers are on strike. Okay, so this is just using the dictionary initialization syntax. I think we did briefly go over that earlier, but basically every single one of these comma delineated key value pairs is going to, the C# compiler is going to turn it into a dictionary.add method call.
Yeah.
And then that
They're what is you referred to in programming speak as tuples.
Well,
It's just that's I kind of have the opposite problem. That's a word that has a specific meaning to me from years of music.
yeah,
Stuff, and I can't quite get my head to latch on to what.
The literal definition of a tuple in programming is an item or a list of type, a fixed read-only list of objects that differ in type. So you could call these tuples, I guess, in the strictest sense.
Right. Okay.
But yeah, then we're passing a new dictionary. Remember, new dictionary does implement. It's not going to show me because it's lame. IEnumerable of key value pairs, which the read-only dictionary constructor takes in. Then it copies all the values into colors. So yes. Sweet.
So you're just using the new dictionary in order to access the initialization syntax,
Pretty much, yeah.
rather than just passing in. You can't set that up for the read-only dictionary directly.
What do you mean? Well, no, I can't use dictionary initialization syntax on read-only dictionary because it doesn't have an add method. Because read-only dictionary is literally read-only. it has to have all the items sent to it through values. Because see, what this does is this initialization syntax, it actually, imagine this being broken out into 2 lines, where it's doing dictionary.add this, dictionary.add that, dictionary.add
of course,
that.
yes. That's the reason you built the read-only in the first place, is because...
Right. So you can't do that.
Okay.
So yeah, so that's our casting cost value object thing. We're going to later expand that with helper methods for like calculating the difference between like mana pools and casting costs and all that cool stuff. So yeah, so I guess the next step is to create the card game environment class, because that's the most important class at this point. And
Spelling. I wasn't quick enough.
I think I spelled that one right. There. And he is going to, not surprisingly, implement iCard game environment. And then he's going to implement all of his members. Actually, he's going to implement all of his members as automatic properties.
Well, just quickly there. What is the shortcut to check all the checkboxes?
They're checked by default. But what I did was I hit Alt-P and then A to get automatic properties.
Okay. Well, because when generating, it's constructors, they come in blank.
Yeah.
Is
In
there
that case,
a hotkey to select?
Yeah, in that case, you just do space. Just hit space because it's already selected.
Space. Of
Yep.
course it's space. I was hitting plus and minus and page up and page, all the usual buttons for it. So
Nelson does not approve.
So basically, the card game environment is just going to have a bunch of lists. It's going to have a list of card collections. It's going to have a list of card definitions. Whoa. And then it's going to have a list of decks. And then we're going to go ahead and say blow up, return collections, return definitions, and go ahead and return decks. And then we're going to go ahead and instantiate all those here. Actually, I'm going to go ahead and rename that to collections. I think I failed at that. What? Whoa.
collections is my precious.
Let's make sure it doesn't do that. And then it still fails because read-only field. Oh, what am I doing? That's not the constructor. For some reason I thought that was the constructor, but it's not.
Yeah, I was wondering.
That's the constructor. Good thing I caught that, otherwise we would be getting some very strange behavior. Okay,
You're
so
speeding
that's...
up.
Huh?
You're speeding up again.
Well, I mean, it's just a bunch of grunt code, I guess. I'm not scrolling.
No, I just mentioned it because I hadn't noticed that you weren't writing that in the constructor either, because it was just going very quickly.
And then he's going to go ahead and have some additional methods, public methods, for adding decks and adding card collections that our factories are going to deal, or not our factories, but our other code stuff is going to deal with. So when we add a collection, what we want to do is we want to say collections.add collection, and then we also want to do definitions.add range collection.cards. And then we get an error because you're joking me, right? IEnumerable of iCard definition. What is cards? Yeah. That was my bad. If you didn't see that, I just hopefully you saw that mistake when I was typing it originally in the last video, but I had the wrong interface type on our iCard collections. That probably did inevitably cause confusion for some people. So I apologize for that mistake. So if we switch over here, now we have add deck. And adding a deck is literally just going to be deck, add deck. And our get card definition is going to do a few different things. The first thing is it's going to do is it's going to have to get the collection by ID. So we're going to bring in link so we can do and if collection is null, throw new, I don't know. I originally actually had a bunch of exceptions typed out, but I'll deal with those later. Argument exception. Yep. And then we need to get our card from the collection. Cards, first or default. Card ID equals card ID. If card is null, go ahead and throw a new argument exception for card ID not found on collection 1. Card ID, collection ID, then let's break, because we're running out of vertical screen space, let's break these out. And then finally return card if it found it. So the get card to get definition is going to be used by our deck builders.
Do you just want to run through the logic of that once slowly?
Well, the first thing we're doing is we're getting the collection, because to uniquely identify a card, you need to give it the card ID and the collection ID.
Mm-hmm.
And that's because there's, especially when we get, I want to support multiple different collections of cards. As far as what date, my idea for a collection is like a database of a ubiquitous database of cards that someone is creating and maintaining and building decks off of. But if someone else has a different set of cards, or like maybe from different sets, or maybe from a different game entirely or something, that's going to be a different collection. So I want to uniquely identify each card by the collection it should be associated with. And this is also going to be used to make sure that people's databases are synced up once they go online for multiplayer play. The first step is we need to get the collection that this card exists in. And if we can't find it, throw an exception. Mm-hmm. The next step is to get the card out of that collection based off ID. If it's null, then throw an exception. Otherwise, just return the card out.
Mm-hmm. I was wondering about, am I right, dex is read-only? Is it? Yes, they're all read-only. And it struck me on the decks surely that changes on a game-to-game basis.
What read-only means in that context is that this reference can only be assigned inside of the constructor. I can still do, from anywhere in the code, I can still do dex.add new deck if we had a deck class. That's still valid. What I can't do, because it's read-only, I can't do dex equals new list of IDEC.
Right.
Because read-only field cannot be used as an assignment target outside the constructor.
Okay, yeah, that's just what I was slightly confused on there.
All right. So yes, that's our card game environment, and really that's the entirety of, well, besides the fact that our card game environment is what's going to be spawning the card runtime, but virtually all he is he's just a collection of stuff. He's a collection of cards, a collection of decks, the stuff that you need before a game starts. Now, in order to actually do stuff with them, we need to actually instantiate card collections and decks. And to do that, in both cases, I created, because I didn't want to, what I didn't want to do is I didn't want to have an add a load from JSON method or a load from XML method. Excuse inside my card game environment class, because I didn't want the loading of collections or cards or definitions to be tied into this one implementation.
Right.
Because I wanted to be able to support loading decks from multiple places, loading cards from multiple places. So what I ended up doing was I went with an extension method route where in combination with a factory for both card collections and decks, I have extension methods that actually have that specific logic for loading up stuff from a particular source. So what I'm going to do is I'm going to go ahead and create an implementation both for decks and card collections. And they're going to be very, very straightforward. Okay, so here's our card collection. He implements iCard collection, has an ID and a list of cards, and that gets sent in from his constructor. Our deck is going to be virtually similar. I mean, it's, well, it might have a
It's
little
going to be similar.
deck. We want automatic. No, we don't want that. I don't know what I did that make that happen. Okay, so then we're going to have these, and then we're going to have a constructor. The constructor is going to take an ID, and iDeck card definitions and details. Okay, so now we have to create our factories for actually creating these decks and these card collections. And the reason I kind of went with this factory route is I kind of wanted to build a tiny little API, because we're going to be, in a lot of instances, having multiple pieces of code that are responsible for pulling information out of JSON files, out of XML files, out of network streams. And so all those instances, I wanted to have a very clean API for actually constructing the decks as data is being pulled out. And so
Right.
I have a card collection factory, which contains a GUID ID and a read-only list. Yeah, this is going to be fun.
Does this not implement iCard collection factory?
No, there's no iCard collection factory right now.
I'm looking at it.
No, you're not.
I can see it in the Solution Explorer.
No, you're not.
Yeah, you can see it all right.
No, you can't. I don't know why I just did that. Okay, let's ignore what I just said.
I thought you were just going to say, let's just ignore what Gavin just said.
Okay,
Hard
so
but fair.
we're going to leave this out of it for right now. Well, this gets a little tricky, because this actually brings in another interface that I don't think we've dealt with yet. And that's the concept of iCard definition providers,
Right.
which are owned by card collection factories. And the providers are the factory, or the card collections are loaded from like a JSON file or whatever, or an XML file or whatever. But then what they do is their responsibility is to create these providers. And these providers are what's going to be like, we're going to be writing a Boo provider and a C# provider and a .NET assembly provider. Those are what's going to actually go out and compile the card types and then send them back through to the card collection.
So when you say provider, it's essentially like a parser
Kind of. I mean, it's
or
basically
a stream reader.
It's you can think of it like a class that returns instantiated card definitions. Now, whether those instantiated card definitions came out of a CSV file or an F# script, it depends on which provider you're using. But the ultimate goal is for them to return these card definitions. Mm-hmm. So we have an iCard definition provider, and he just has one method. Which is load definitions.
It's handy.
Yes. So now our iCard collection factory, he's also going to do the grunt work for dealing with providers, because that's a kind of an obnoxious problem that I don't want to have to redo for every single place that a card collection can come from. So I decided to put it in the factory. So basically what he's going to do is adding a provider, he's just going to add this provider type, which is a type from some loaded assembly. And then he's going to get arguments for that type. And the reason I have a provider type and arguments is that a provider can be passed in a key value just a string structured doohickey thing for arguments that provider might need. So, for example, I might have a Boo file system provider, but he might get an argument saying, load all the scripts in this path. Or it might have a network stream provider that says, load all the providers from this endpoint or something like that. So that's why I have these arguments. So the add card provider, all it's going to do is it's going to first say if the type of iCard definition provider is not assignable from the provider type you passed in, throw new argument exception. And then let's break that out. And then pass in provider type full name. And then finally, all he's going to do is do providers add, tuple create, provider type, arguments. So the create card collection, that's actually going to go out and spool up each one of these types that have been sent in. Why you all... Oh, yes. That would have been a problem. Let's go back real fast and pretend that I didn't not initialize that. Basically, I didn't have this initialized to anything at the moment. I just threw in a constructor to initialize it with. So our getting card collections, basically the logic behind this is it's going to run through this list, get all these types, go ahead and instantiate that type, and then cast it to an iCard definition provider, and then call the .load cards from it. So we're going to start with a private IEnumerable iCard definition provider called getProviderObjects. He's going to loop over all the providers that we sent in. He's going to say if the provider item 2, which remember is the arguments, if it's 0, go ahead and yield return a cast of an iCard definition provider activator dot create instance from provider dot item 1, and then don't pass in any arguments to his constructor. Otherwise, if they did send in some arguments through the read-only collection, then go ahead and yield return an iCard definition provider activator create instance provider item 1, which is remember is the type that we're instantiating, and then provider to item 2, which remember are the arguments. This is the overload of create instance that we're using. We pass in the type of the object or the type of the class we want to instantiate, and then we pass in a list of arguments to pass into the constructor. So this will basically say if the person provided arguments, go ahead and invoke a constructor on the provider that contains those arguments.
That's right.
So the next step is I'm going to create another IEnumerable of iCard definition, and we have to bring in a namespace to get that, called getCardDefinitions, obviously, and it's basically going to be getProviderObjects.select many, bring in .link or system.link provider.load definitions. So what this is doing is it's are you familiar with the select many operator, Gavin?
No, but I think I can deduce from context that it will select many. That's just a guess.
Very good, very good.
Well, select many, what it's going to do is, select, right? When you select, you return one item, and that item essentially gets projected on or replaced.
Projected on?
I don't think he's used to the concept of projections.
No, I'm not.
The select statement is essentially what's called a projection. You have ints equals new 1, 2, 3, 4, and then if I were to say squares equals ints dot select I times 2 or I times I. Okay, so this is a projection. Basically, we're taking every single item in this ints array, and we're projecting on a different value.
Mm-hmm.
The select many, basically what it does is the exact same thing as select, except for what's returned is actually an IEnumerable, and the IEnumerable then gets appended to the list. So what's going to, think of it like flattening. Basically, we're getting all the IEnumerables of .low definitions from all of our providers, and then we're flattening them into one list.
Okay.
Funny bit of awesomeness, every single link operator can be implemented in terms of select many. And I've been meaning to do that at some point on video because it's really cool. Yes, you can even do .where and .select and .any and so on with select many. So our crate card collection is just going to return a new card collection with the ID that we set and get card definitions .toList. The reason I'm doing .toList there is because these are iterator blocks. This is an iterator block. And basically, if I didn't do the .toList, every single time this was enumerated on or ran through a for each, this code would execute.
Right.
So doing the .toList copies all the values out and then sends it off to the card collection constructor.
Cool.
So then finally we have the deck factory. Deck factory is going to implement the iDeck factory. And he is going to have a bunch of stuff. He's going to have a reference to iCard Game Engine, and we'll see why in a second. Or environment, sorry.
Mm-hmm. Called environment.
Did I say that wrong again?
Yep. To be fair, you are at least consistent. You spell it wrong exactly the same way every time.
Well, that's true.
Something.
Well, if English was always spelled phonetically, I wouldn't have any issues.
Phonetically, it's not even spelt phonetically.
I know, it's depressing. Okay, so we do need one more thing here that I didn't do inside the deck. And that is remember our implementation of, or our interface for the iDeck card definitions?
Mm-hmm.
Yep.
We don't have an implementation of that yet. So, yes. So what I'm going to do is I'm going to go ahead and create an implementation of that. So I'm going to create an internal class, and actually most of these classes are going to be internal. I'll lock them up in a minute here. He's going to exist within the iDeck.
This is something I've not come across before, is classes inside other classes.
Yes, you can nest in infinitely if you wanted to. But it allows you to do like private classes and stuff, which is really cool.
That sounds, again, like a Nelson's Corner
Yeah.
to itself.
And all it's going to have is that it's going to have another method called addCount. And basically that's the only way you can mutate this, by adding count. But obviously that addCount method is not exposed by the iDeck card definition interface, so it's safe to leave that mutating method on it, even though the interface itself is immutable.
And mutating just means what mutating means, presumably.
Yes,
It's
changing in any way.
Yeah. Okay.
So, deck factory. So we're going to go ahead and have to have a list of these guys. And it's going to have to be a list because we're going to mutate it as the execution goes on. Then we're going to have an ID, our deck details, and then our deck factory is going to go ahead and take in a iCard game environment. I'm going to call it ENV. Yes, so set ID is going to be pretty awesomely straightforward. Set details is going to be pretty awesomely straightforward.
Don't forget to generate your
Man, you made that look straightforward.
Yeah, I don't know. I can't type anymore. So our add card, it's going to get a collection ID, a card ID, and a count of how many cards that should be added for this particular card. So the first step is it's going to get the card, obviously, by going to environment.getCardDefinition. Or not. Then it's going to make a deck definition, or it's going to first see if this card already exists within the definitions we already have. So bring in link d.definition.id equals card.id, and then if deck definition is not null, go ahead and do deck definition.addCount count. If it is null, then go ahead and do definitions.add new card deck definition, and that's not an initializer. I want a constructor, and we're going to pass in the count and the card definition. And then to create a deck, all we do is create a new deck with this ID, these definitions, and these details. So yeah.
Mm-hmm.
Yep.
And of course, I again forgot to do that. All right. So yeah, basically all that's left now, we have the entire infrastructure in place for being able to add cards and add deck collections. I'm also going to go ahead and internalize our card collection class, because we don't need this outside of this assembly, because it's handled by our card collection factory, and we don't need our deck either, because that's handled by our deck factory. And now all that's left is really just implementing our load collection from JSON and our load deck from JSON file and so on methods. So I think maybe it's a good time to split the video.
Yeah, it sounds great to me. All right, so with that is going to wrap up this video. Unless, Gavin, of course, you have any final questions?
No, that looks like a good place to stop.
Okay, well, thank you guys very much, and we will see you in the next video.